All right, kids, let's complicate things. This is a distance equals rate times time problem. Let's quick write that out. Distance is equal to your rate times time. We have a cattle train that left Miami and traveled towards New York. 14 hours later, a diesel train left traveling at 45 miles an hour in an effort to catch up to the cattle train. After traveling for 4 hours, the diesel train finally caught up. What was the cattle train's average speed? So this is what we're looking at, okay? We're looking at two different things, but what we also have is the fact that they're both the same distance. I don't care about Miami and New York. That doesn't matter. What happens is you have the diesel, no, the cattle train. So we'll put C, and it travels. Okay, now we also have the diesel train. Boom, boom. Now they both have the same distance. So what I need to do is figure out the rate for each and the time for each. A cattle train left Miami and traveled towards New York. 14 hours later, a diesel train left traveling 45 miles an hour in an effort to catch up. After traveling for 4 hours, the diesel train finally caught up. So this is what we know. We know that the diesel train, its R is 45, so I'm going to replace R with 45. Its T is 4 for 4 hours. The cattle train, we don't know, and that's what we need to try to find. So we'll call you R, but what we do know is that it took 14 hours of traveling. Now, this distance is equal to this distance. So what we're going to do is set up an equation of R times 14 is going to equal 45 times 4. Now, R times 14 can be written as 14R, and 45 times 4 is 180. Divide both sides by 14. Because 14 is being multiplied to R, we got to do the inverse, which is divide. And it's not pleasant. We are going to get 12.857. So we'll leave it at that. 12.857 kilometers per hour. We'll write that over here. All right. So the distances are the same. And we just did rate times time, set them equal to each other. Fun.